Hi, grade 11s. Today we are going to solve quadratic equations by using a method of substitution. Some people call it the K method. You'll recall that the quadratic equations must always be in the form ax squared plus bx plus c is equal to 0 for you to be able to solve it. Let's look at how we can solve these quadratic equations or some of them by using the K method. It's an easy method. Let's look at example 2. Here's an example 1. It says solve for x in this equation here equals 9 over that denominator over there. So I need to solve this. If we look carefully, you can see that this expression over here, the x squared minus x minus 3, is just the same as x squared minus x minus 3 over there. If I may highlight the things that are the same, so it's x squared minus x minus 3 is the same as that one over there. So what we do now, we let this thing that is pink here be k. That's where they say K method, right? So what we do, we let, right here, I let x squared minus x minus 3 equals k. This will make things easier for me to solve this problem. Okay, so where there is this thing here, I'll just plug in k. So therefore, let me just put this thing here like this so that I'll come back to it later. So that instead of that, I'll just plug k. So k equals a 9 over k, because I said I'll put k for this thing here. Now this looks simple here, so because now I can find the LCD. So the LCD is k. I can multiply both sides by k, so therefore it means that k squared will be equals to a 9. Now we take a 9 across, I get k squared minus 9 equals a 0. I can factorize this because it's a difference of two squares, so k minus 3 and the k plus 3 is equal to 0. So therefore we can see here that k is equal to 3, or from here that k is equal to minus 3. But remember that the question was saying solve for x, not to solve for k. So what we're going to do, we are going to replace it back, because it said k was this thing. So we'll take this thing here and plug it back there and also there. So instead of k, I put that thing back. So therefore now I've got x squared minus x minus 3 equals a 3, because k is this thing here which is over there. Or instead of k, I plug the thing again. So x squared minus x minus 3 equals minus 3. Now this looks simpler because now I can take a minus 3 to this side. Then I get x squared minus x and minus a 6 equals 0. And now using your grade 8, grade 9, 10, 11 mathematics, you can factorize this. So it's x minus 3 and the x plus 2 equals 0. So here we can see that x now is equal to 3, or x here is equal to minus 2. So those are two values from this k when it is 3. But when it's like this, we can take this minus 3 across. We end up with x squared minus x equals 0, because minus 3 will become plus 3 here and then cancels off. Now factorizing this, I get x into x minus 1 equals 0. So from here I can see that x is 0, and from here we can see that x equals 1. So we've got 4 values of x when we solve that. So simple. Let's look at another example. Example 2. This says solve for x here. So we're still going to use the K method. This is x squared minus 2x something there minus 2x squared plus 4x equals 3. Sometimes you've got to look and open your eyes and look if there are any things that look familiar. Note, if I were to factorize these two terms here, see what happens. I get this is x squared minus 2x, which was squared. Now if I take out only minus 2, then I'll be left with x squared then minus 2x, which is equal to 3. Can you see now that this thing over here, the x squared minus 2, is same as the x squared minus 2 over there? That's where we plug in our K method. So therefore we say we let the x squared minus 2x equals k. So where there will be x squared minus 2k, to x, we'll just plug in k like there. So therefore I plug in k, so I'll have a k, but it is squared, minus 2 times the k, which is equal to 0. Now I can factorize this. If I factorize this, the common factor, which is k, into a k minus 2, which is equal to 0. So from here, it means that k is equal to 0. And from here, it says k is equal to 2. Note if k is 0, it means that x squared minus 2x is 0. So I'll have x squared minus 2x equals 0 because I'm substituting that thing back here instead of k, because I'm not solving for k, I'm solving for x. So same thing here, substitute back the x squared minus 2x. Now I say is equals to 2. So when I factorize here, I get x into x minus 2 equals 0. So I get here x is 0. Or from here, I get x is equal to 2. So I've got two answers over there. If I come here, I'll have to take this to the other side. Then I get x squared minus 2x. Take this across, is minus 2 is equal to 0. Now wait a minute. Can I factorize this? No. Now recall that if I don't know how to factorize an expression, I can always use that formula which says x is equal to minus b plus or minus square root of a b squared minus 4ac all over 2a. So Andrew said that if that is the case, it means that we need to know what are the values of a, b, and c. If we know what is a, what is b, what is c, it means that we'll get an answer. Now you can see here that the a value from this expression here, our a value, let me push this a little bit. So I get a equals 1, the b equals minus 2, and then I get c equals minus 2 as well. So therefore, I can substitute this in the formula. So the x here is equal to minus, and the b value is minus 2, then plus or minus square root of the b, which is a minus 2. Remember, must put brackets in, times 4 times a, and a is 1, times the c, which is minus 2, all over 2 times my a value, and my a value is 1. So x is equal to, we know what this one is, there'll be a positive 2. So for the plus or minus, now I need to find out what's the answer under the square root. So let's see what the answer, let me take calculator so that I don't make a mistake. So there's a minus 2, so minus 2, which is squared, then minus 4, open brackets, there's 1 close, then I've got a minus 2 close there, and then what's the answer under the square root? It's a 12. So I've got a 12 here. So this is all over 2 times 1, which is 2. Now we know we can't find the square root of 12, but we can do things here. So when you simplify this, it means that we get 2 answers here. One will be positive, the other one will be negative. However, the square root of 12, I can simplify this, and I will get a 2 plus or minus square root of 12 is the same as 2 square root of 3. Is 2 square root of 3. So this is all over 2. Let's check again. Square root of 12. If I say what is square root of 12? Square root of 12, what is it? It's 2 square root of 3. It's 2 square root of 3. So I've got 2 answers here. So one answer, we said it is x is equal to 2 plus 2 square root of 3 over 2, or the other one is x is equal to 2, because there's a minus there, minus 2 square root of 3 all over 2. When we simplify this, we can see that there's common factor, which is 2. We'll cancel this. There's 2 and the 2. The 2 is a common denominator for both of them. So x is equal to 2 over 2, which is 1, plus 2 root 2 over 2 give us square root of 3. So then here we get x is equal to, again, 2 divided by 2, we get 1. And the minus 2 square root of 3 divided by 2, we get minus square root of 3. Okay? So that's the one answer. So let's look at another example. Let's suppose now they give us this problem over here. It's a nice problem that they gave us. This one here. They say solve for x here. Again, you can see that over there is 3x squared plus x is the same as 3x squared plus x over there. So that's where we put our k. So we say let 3x squared plus x equals k. So where there is 3x squared plus x, I'll plug in k. So let me put that in bracket again. So therefore I'll put k there. So I'll have a k minus 1 plus 1 over a k minus 3 is equal to 0. Now, what is the LCD? The LCD is k minus 3. So I'll multiply each term by k minus 3. So which means that I'll have a k multiplying the k minus 3. The minus 1 will multiply the k minus 3 plus 1 over the k minus 3 will multiply with the k minus 3 equals 0. The 0 will also be multiplied by k minus 3. So what happens is this will give us the k squared minus 3k. Multiply this, you get minus k plus 3. Now these ones here, this cancels that, so I'm left with a 1 here equals. Now 0 times anything here will give us 0. You can see a quadratic here. When you collect like terms, you'll get k squared. This and this is minus 4k. And this and this is a plus a 4, which is equal to 0. Now it's a simple quadratic which you can factorize. You get k minus 2, and k minus 2 is equal to 0. Obviously, you can see that k is 2. You can say, oh, k equals 2, but it's meaningless to repeat the thing. But we know that k is 2 is one and same thing. So therefore, I can substitute the k, which is that thing there. I take that thing back to there. So I now have 3x squared plus x is equal to 2. So I can take this to the other side and get 3x squared, then plus x minus 2 is equal to 0. This I can factorize, unlike the previous one which I couldn't, but this one here, if I factorize here, I can put 2 brackets like n grade 10. So factors of 3x squared I know is 3x and then x there. So for 2 it would be 1 and 2, but I need that one to give us 1, so I put a 2 here and put 1 there to get a positive there, assuming that this will be positive and this will be a negative. And therefore from here we can see that 3x is equal to 2, and therefore x is equal to 2 over 3. Or from here we can get it x is equal to minus 1. So there are 2 solutions for this one here. X is 2 over 3 and x is equal to minus 1. Now if you can try a few from your textbook from grade 11 Siavula maths textbook, chapter 2, do 2.4 which says substitution, but on exercise 2.4 just do numbers 1 up to 6. You'll enjoy them. Good luck, ladies and gentlemen.